Hi, in this video we will continue building a decentralized messaging app. In our previous video, we coded a system that we had a fixed sender and a fixed receiver, and when two of these devices were on the same connected to the same router, we created a code that can successfully encrypt a message, send it to the receiver, and then decrypt at the receiver. Then the receiver could see it. In this video, we will improve this code by making this messaging two-way. So both the sender and the receiver in this case will receive message, and which means that there won't be any fixed sender. Both parties can send and receive. So let's add that to our code. To do that, I'm going to create a different file, and I'll call this program program1.py. You can name it whatever you want, and to have to for the computer to both send and receive stuff, we need to do threading. So we will multi-thread. Our main code will be responsible for sending, and we will multi-thread for receiving. Okay, and we then need to import the libraries too, because we will use socket connection and we will use cryptography to encrypt our message. Again, we need a fixed key, right? And then we again need an IP address, but this is for the client. We will have a server. Again, we need a port, but actually we can assign them later. So let's create our main loop. So if name equals to main, meaning if this is the code that we run directly from the terminal, we'll first ask a question. Let's name it mode equals to input as server or clients, and we can take this into parentheses. Then what we are gonna do is we are gonna strip dot lower in case they enter a capital letter. So why do we need this? Because even if we are making this connection two-way, we still need the server and the client. The server will run first, and then the client will connect to the server. Okay, then we gotta say if mode equals to s, meaning if we are the server, then connection equals to start server. We are gonna call start server later. Else connection equals to start clients. Yeah. We also need the IP address too. So IP. So let's say IP equals to. Let's also copy it to now. Okay. And then we are gonna start the client. So this is basically what we need. And after we start stuff, right? Start our server, start our client. After we run the start client, the client will connect to the server. We then will receive and send stuff after we connect. So to receive stuff, we get a multi-thread. So receive thread equals to. This is where we are gonna do it. Multi-threading, threading dot thread parentheses. Inside the parentheses, we are gonna say target equals to receive messages. So this is the function that will run. Receive messages function will run. And after that, we need arguments. We are gonna send the connection, and then daemon equals to true. So we need this because when we end our main function, we don't want this receive thread to be running. We want to end it. That's why we say true. And for arguments, we enter tuple because this is not actually, yeah, we enter tuple, but that's how it wants you to send your arguments. This multi-threading works like this. And then we need to say receive to red dart start to start it. So yeah, we start our multi-threading, and then we need send messages. So our multi-thread, we thread multi-thread to receive messages, and in our main function, main file, we are gonna send messages, right? So this is all we need. Now let's code the start server. Define start server. Okay. To start a server, we basically need the receiver part. So we need all of these things. I explained these in my previous video. I just copy and paste this here. We also need port, obviously, 5000. Host equals to, let's see what we entered as host. Yeah, empty string because we allow any device to connect to our own device. We have listen, which is 1 because we only want one device to connect. Cool. Then we also need to add this too because this is where we accept the connection. Then we return con, which is the connection. Cool. So this is basically what we did in my previous video. I did the same thing here. For the define start client, it will be similar again, but this, yeah, okay, sorry. We will have the same things, and I also need to copy this too because we will encrypt and decrypt for it. We need this and this, so it is the same thing I explained in my previous video. And we connect. Yep. Let's see, we don't have anything else, right? Yeah. Then we return client too. Cool. So this is again what we did in our previous video. And then we need to have the define receive messages, right? And this also accepts connection. So let's say connection as an argument. It accepts connection as an argument. So how do we receive messages? Again, we can visit our previous code, and actually we can just copy this, but yeah, like this, since we use the same logic, but instead of con we use connection. And we also need the close because we don't want our server to be open indefinitely, right? Connection dot close. I guess we don't have any servers since we defined it here, so I guess we can delete it. Yeah, I mean, you can just also add the server dot close too as an like argument here, then like run it. I mean, you can add server as an argument here and also here, then you can add server.close in your receive message too. Cool. So this is also the same actually, but before moving on, I want to create buffer 4096, and I'll set this as our buffer. Why buffer? Why did I set a global variable? This is not, yeah, why did I set a buffer outside of our functions? Because, well, we are gonna accept maximum in here. We accept maximum amount of bytes, right? So a buffer decides that maximum amount of bytes. I'm setting a buffer outside of our loops because, like, when we are accepting stuff elsewhere in our code, for example, in the future, we will add files, sending and receiving files. We will probably use the same buffer in that files, receiving files too. So that's why I set a global buffer here. And for sending messages and messages, it's pretty similar actually. What we are going to do, but we also need to add this as an argument too, since we need to access that to send something. To send messages, we can basically copy this and paste it, because again, it is the same. And instead of client, we say connection. Great. Now, if you run this Python file in both of your computers, the same Python file, adjust the IP, generate your own Fernet key, then you should be able to set a private channel between two of your computers. Yeah, actually, let's try it. Terminal, Python, program1.py. Let's set this as server. It is running. Python program2.py. Oops, sorry, Python program1.py. This is going to be client. We connected. Actually, we can add a message that indicates we connected, but still, whatever. Now let's send hi. Again, we received the hi. Can you see this? See, now there is no fixed sender or receiver. We have a server and a client instead. It basically works perfectly fine. Let's type something random. See, we can see it. We can type question mark, and yeah, we can see that too. Okay, cool. So in this video, we added multi-threading to our code. In the next video, I'm planning on adding file transfers to our code, and in later videos we will add voice message. We might improve the encryption algorithm, since Fernet isn't the best encryption algorithm, because, well, you need to transfer the key somehow to other computer, and to do so, like, you might need to use some messenger app, which doesn't make it private because you're just transferring your key. Yeah, we might do some public encryption. Yeah, let's see where this goes. So that's all for this video. Have a great day.